Welcome back. So the question here is a 14.5 kg mass fastened to the end of steel wire or unstretched length 1 meter is whirled in a vertical circle with an angular velocity of 2 revolutions per second at the bottom of the circle. The cross-sectional area of the wire is 0.065 centimeters square. Calculate the elongation of the wire when the mass is at the lowest point of its path. Mass of the body is 14.5 kg. Angular velocity omega is 2 revolutions per second, uh, which is 4 pi radian per second. The radius of the circle smaller is 1 meter. Tension in the wire when the body is at the lowest point is capital T. So capital T is mg plus m omega square r. So if we put in the value of mg, omega and r, we get the T to be 2431.84 Newton. Cross-sectional area of the wire is 0.065 centimeter square, which is given in the question itself, and the Young modulus of steel is 2 into 10 to the power 11 Newton per meter square. So delta L is FL divided by AY, which is if we put in the values of FL, A and Y, we get the delta L to be 1.87 mm.